This week, our final week, we're going to be building a website for our project. And you're wondering, well, this is AI camp. Why do we need to build websites and apps for our AI? The main reason is that, first of all, sharing is caring. And if you guys aren't into that type of meme, then the most important thing is that you're building something. And how useful is it if you're not going to be able to show anyone or to have anyone use it? Even if it's the best thing in the world and it's perfect, it's not going to be of any value if no one gets to use it. Another thing is building a website from end to end allows you to practice coding, allows you to understand how these things are put together. You work with them, you play with them every day. So it'd be good to understand how these things work. Like you're on your smartphones probably, I'm guessing, at minimum 30% of your entire lives, if not more. And then you're interacting with it. Sometimes something goes wrong. And thankfully we have competent engineers to fix them as they go. But it's definitely, if you're going down this road of technology, it's good to understand how this works. But importantly, if you ever go down and want to build something and want to sell it to someone, or you want to create an idea for people to use, it's also a way to get feedback. And there's nothing more important than feedback because it allows us to test, well, I think people need this. And for example, later on, you're like, okay, I built this thing and now I'm sharing it with everyone and I'm getting all sorts of feedback, whether, well, it's not really that useful or, well, I wish it did this. Getting that feedback only allows you to make things better. So whether it's negative feedback or positive feedback, feedback is feedback. And you can always use it to improve what you're making or what kind of product you're selling or even for yourself, how to make something better. We're going to talk about a couple things. We're going to talk about how websites and apps generally work. There's this whole back and forth of requests and responses and the gateway for all information. As of today, we use APIs. And we're going to go a little bit more detail about the back end as well as the front end. Let me just ask real quickly, does anyone have a sense what a front end is? Anyone have a sense of what a back end may entail? If not, we're going to go into that. We're going to use a restaurant as an analogy to help you kind of picture these things together. And then how it's being done in the world today, how people put things together, test what they're putting out there, and how do they push it out so that people can use it. Can anyone describe when you open up your browser and type in, let's say this website, emotion.aicamp.org, or any other website? I mean, you open up your smartphone, you click on an app, imagine what's actually going on behind the scenes. What's really happening out there is that once you click, say for example, I'm gonna minimize this. I'm gonna open up a web page. So when I enter this web address, I get this, right? When I enter a web address, it actually is sending a request to the bing.com web server. The bing.com will take that. You're just actually just hitting its front door and it says, oh, someone's at my front door. I'm going to provide a response. And a response comes back, oh, my response is the search engine with a website and a search field and all that. So a lot of times is that when you type in a URL, you're making a request. The URL goes to somewhere in the cloud. In a nutshell, cloud is a place, like it could be your backyard, it could be in someone's home, it could be in a building. But the idea of a cloud is it obfuscates the physical location of where these computers are. These computers are probably in a data center in Las Vegas or South Carolina, but basically to the average person, to the people who are using these services, totally transparent. I don't really care where it is. All I care is I get my service. So the cloud is a general concept. This is where all the computers, all the servers, and all the information is stored. When we use a URL, we're using that to find where these machines are, and these machines could be as close as a data center in Silicon Valley, or it could be as far as a data center in somewhere in Africa. Where they all are, you could definitely look them up, but what each machine in those data centers are, you'd have to probably dig a whole lot deeper, and it's probably not that available to understand. But the idea is that we call it the cloud because we don't want to describe so much detail of that. It's just, it's up there. We load data there. We get our services there. Nothing's running on our computer. We're just using a web browser or some sort of app to interact with it. This is the typical thing. Either I'm on an app or I'm on a web page. I'm making a request. The request goes to somewhere out there over the rainbow, and it comes back and it says, here you go. And it's usually, if it's a web page, it provides you HTML and it renders onto your browser. And typically you look, if you ever do this, so let's say I'm on bing.com, right? It gave me back this, but behind the scenes, I can look at the page source. Your browser is reading all this information, which looks like there's like a bunch of garbled stuff, but this is all HTML code with some style sheets and some bunch of stuff. This is definitely hard to read, but that's what's being spit back at your browser, and your browser's taking that and it's showing you this. As you can see in the example I showed earlier, there's a lot going on there. It's broken up into different sections. There's headers, which is the top part, and you can see how the code is broken out. It's tagged with head. The navigation bar, it's tagged with nav. And within the navigation bar, there's like, different menus. So if you look at, say, for example, the head, you don't really see much, but it's in here. That's part of the head nav bar. And then you'll have different sections within your nav bar, which kind of saw the different menu items in your nav bar. And then you have body, it's not shown here, but you'll have a body which has your content. And then you also have your JavaScript. So JavaScript is kind of more of the functional code of what we use to browse to websites. It is definitely extremely powerful, and you could really do many different things with JavaScript. I can't even begin to describe what you can do with JavaScript, but when you click on a button and it does something, like not necessarily go to a page, but maybe pop up an answer or take in your response, that's usually powered by JavaScript. While JavaScript's all powerful in helping you work through your web page, at the same time, and I don't want to entirely influence you guys, but in my personal opinion, if you're ever programming JavaScript, you might want to do this in a pool somewhere. You don't want other people seeing you cry when you're programming JavaScript. And the reason why I'm saying this, JavaScript can be very challenging to use. If you program in Java, if you programmed in Python or C, there is some dogmatic structure to a lot of our programming. But with JavaScript, unless you're using a framework in JavaScript, JavaScript can be kind of like the Wild Wild West. And that term Wild Wild West means a little bit, there's some rules that you can kind of bend here and there. And it can be confusing because depending how one person programs in JavaScript versus how someone else programs in JavaScript can be a little bit daunting. So the other thing is, in today's world, we use API, application programmable interface. If I was to use one word to describe it, it's kind of like a gateway. It's kind of like a contract. So imagine if you're going to, it's like, in order for me to get this, I need to provide. So imagine you go to a different country and you guys get the benefit because most people nowadays speak English because a lot of countries pretty much want their students to learn English. But let's say you go to a country, rural area, you want to buy that, I don't know, that souvenir. So in some cases, you're going to have to figure out, okay, in some cases, I got to learn that language. I got to figure out, okay, how to say, how much is that? And let's say you don't want to pay too much for something. You're going to say, okay, you're going to have to figure out how to say in their language, how to negotiate. So an API is kind of like the contract of the language. So if I'm talking to Google, I need to understand how to read the API in order to interact with Google. Just like if I go to France and then I need to talk to someone who only speaks French, I need to maybe learn how to understand some keywords in French in order to get things going along. So it's kind of like that. And we use JavaScript to call those APIs. And the APIs will now the API is understanding what you're kind of asking it to do. It's going to go through the cloud somewhere and gets data and give you back the data. Just like how Bing engine, you put a search term. You don't see the API, but the Bing engine will take the search term and put it into the parameters, and you're following their rules in order to communicate with their server. And the same thing, JavaScript's kind of doing the same thing. It's putting in the terms, it's putting in the parameters, it's making a request to API. The API is going to, oh, okay, I got a request. I understand your request. I'm going to go back and I'm going to get data and then give you back the data. And that's why you're getting your, whether it's, what guys are you, whether it's rotten food or other types of things you're looking for your object detection project. And basically, you have your HTML scripts, your API, and the API will get your data. The data comes back, and you see it on your web browser. Or in the case of smartphones, you see it on your app. All right, so this is kind of scary for me. Why is there one backend to rule them all? A lot of it has to do with API being your interface, and all the data you need is basically in the cloud. You really need to understand what you're given on the front end is all driven from the back end. It provides your data, it provides all the calculations it needs to do. All your front end is doing is taking that information, showing you, but how you get that information, what you get, how it's being stored, how it's being calculated, it's all happening on the back end. And it applies to your project for this week, because some of you will be working on the back end to connect your AI model that you've trained to an application engine that will help show your product to the front end. And if you think about it, so have you used Facebook on your, so imagine you're on your computer and you go to these websites, right? But you can also use your mobile phones to get to them, right? You download an app, you can access Pinterest, or you can go to the web browser on Pinterest. So what's happening here is, why we say is one backend to rule them all. It is literally one system in the cloud somewhere, but you don't know that. And it provides the information for the smartphones on your mobile app. Let's say, for example, we're using Pinterest. Pinterest will have a website. We can look at the website on our browser, or we can look on the browser on the phone, or they have their own app, which you can download. Pinterest may not be a great example for this one, but there are applications out there that also, instead of using mobile app or websites, they're directly communicating with each other to get information with each other. And they're all using APIs to communicate with each other. But it is one backend providing the services, providing the information, providing the calculations to your mobile app, to your websites, or to each other. So we're going to use an analogy here. Visiting websites like going to a restaurant. Can anyone kind of, well, think about that for a second. You sit in a store. So you're going into the URL. You're typing in www. In our case, aicamp.com, or you can go to google.com, whatever it may be. You're in a restaurant. You want to get a menu, right? Unless you're going there just for water, which after some moment, I think they'll ask you to leave. But you're getting a menu. And basically, in the case of a restaurant, you're asking a waiter, hey, can I get a menu? And they give you a menu. In the case of a website, I'm making a request through the API to get something, and I'm getting HTML. So I get a bunch of information. In the menu, I'm getting a bunch of information. And let's say I want to order some food. So I want to order a chicken parmesan or something. And I tell the waiter, hey, I want some food. So you can kind of see the waiter is kind of like your API dude or dudette. And on the computer side, the API request is, taking your request for something. Let's say I want to look up something if I'm on Bing or Google, and it's going to send it to the backend using some form of JavaScript. And then once the waiter has your order, that person's going to go back into the kitchen and going to say, hey, table number 2 wants, eggplants and fried up frog legs and escargot. I'm just making this up. Sorry if I'm grossing you out. But they want all these things. So then, likewise, the API is making a request, and the server in the back, or in the kitchen, so to speak, is trying to build together that calculation, or in the case of Bing, is trying to collect all the information about that search term that you're looking for. And and the head chef is telling all the cooks and the pastry chef and everything. He's like, we need things. Go to the freezer. We need the chicken. We need the zucchini. We need this, and they're bringing that stuff up. Whereas on the back end of a computer, they're saying, okay, we need to grab this data. We need to grab that data, and they're going to go to a database. They're going to grab it and bring it over to the cutting board, and they're going to prepare the information. Whereas in the kitchen, likewise, they're preparing the meal. And then ultimately, when the meal's ready, or in the computer side, when the computation is ready, or the presentation of the how the data is formatted is ready, the waiter is going to come by, get your meal, and deliver it to you. As well as the same for a computer side, the response is going to grab the prepared information and get it back to you. I'm not sure if you like Applebee's. This is a picture we picked. But so you can imagine the storefront being your front end. There's HTML, there's JavaScript, there's CSS. But the front end, there's a lot going on the front end if you think about it. They don't just put up a wall and a door. They put like a big logo on it. They put like little notes on it. They put like little the sides here and there. They decorate it with a facade. They put like colors on the image. They put big pictures. They do quite a bit to make the site appealing, to make you want to come into their store. Like, would you go into a store if it had garbage out in front, or like the sign was upside down, or if it's not maintained? Probably not. So that's the idea of kind of like, if I go to a website, it usually looks pretty nice. If not, I'm not going to spend a lot of time there. Same thing with a restaurant. I mean, usually I go there for the food. I know the service is good, but it also, if I'm just walking by, I say, hey, maybe I just want to check it out because it looks kind of interesting. There's something attracting me to go there. Whereas the kitchen is your back end. People who are doing the, chopping up the vegetables, or preparing the meats, or making the sauces, the sauciers. And same thing with this back-end computer. There's different things we're using. We're using an app engine. We're using Python. We're using frameworks. We're using databases. We're using all sorts of things going on. So the restaurant, I think, is a pretty good example of how our websites work, if you were to ever use that analogy. And your waiter or waitress are basically carrying out your requests and responses. Okay, so we kind of talked about this a bit. I'm not going to go into too much detail other than that we have a lot of servers out there. Some of it's like storage data, just like our their freezer locker. Well, one of the challenges is that if you have 1 million users hitting your website, your server is going to be pretty busy. Just like if 100 customers come to your restaurant's going to be really busy. So you're going to need to augment your staff. You're going to add more. You need more waiters. You need more waitresses. You need more table space, things like that. In some cases, especially when you're using AI, or if you're trying to crunch like a lot of numbers, you're not just going to have a database. You're going to have a central data warehouse. It's housed, and that type of stuff houses a lot of data. Just like, kind of like, can you imagine Costco? And you have like something like a grocery store or supermarket. Costco is huge, and basically it's a wholesale warehouse. It has a ton of stuff in it, whereas your supermarkets and maybe grocery stores, maybe not as much as that. So we gotta have our products, and our products need to be built on code. But then our products need to have some design to it. And why do we have design? Design is to not just attract people, but also try to guide them to do something. And we need data because data helps us determine how fast our system is running, or if our system's having issues, or if, like, are we getting a lot of people? If not, then we need to figure out how to get more people to use our website. Obviously, to build these things, you need to code it, and you need to test it, because you don't want to put crappy stuff out there. If it's crappy and it doesn't work, no one wants to use it, right? And then you need to deploy it out to somewhere where people can use it. So for this week, we're going to be breaking up into different teams. There's some of you that probably need to still evaluate your model. So it's important that you test it, because a lot of things that you collected from a data perspective, you're going to find whether or not your model really works or not. You're going to have to tweak some values based on what kind of results you get from your test. There's some hyperparameters, like your confidence levels and your IOU thresholds, or if no matter how much you tweak, it might not get you what you want. Then you're going to have to look at, hey, there's something wrong with our data. So that's an iterative process. You need to test it. You need to see, if you're getting good results or not, and kind of adjust it. And then you might need to retrain. And it has happened before. It is perfectly normal. There's going to be another team that's going to have to design the site. This is your storefront. You want to make it attractive. You want to make it appealing. You want to get, grab all the content, like why'd you do it, or the reason you did it, or what you're building. And you're going to write front-end code. We're going to use a tool to help us with that. So it's going to be custom HTML, CSS, and JavaScript. And there's going to be a team that needs to write the backend. They're going to that's the team that's going to integrate your the weights that you train with some pre-developed code and make it work with what we're using is Flask to manage the website. Again, we talk about it's important to test your model rigorously. So on your website or app, you're going to present confusion matrix to show how well it performs. So if we use an example here. So your first page will have a bunch of stuff, but your second page, when it gets a result, it'll have a confusion matrix. So you're to explain why it's so good or why actually you miss sometimes. That confusion matrix will kind of tell you, how well things are doing. And so when you're testing it, just make sure that you're adjusting your parameters to get the best results you can. And this is basically what data scientists are doing. They're evaluating the model. They're adjusting their confidence levels, their hyperparameters. They're evaluating the precision recall curve. Importantly, if you're designing a website, you want it to tell a story. And why do we tell stories? It's probably one of the best ways to convey information. Imagine you're hearing these lectures over and over. It can get a little dry, right? But if you tell a story, then the story kind of personalizes it, allows you to relate to it. There's an aspect to storytelling that allows people to be drawn in. In some cases, if you have a video, you can use that too. Anything visual will pull people in. If you give people a bunch of text on a web page, I'm not going to look at it after a certain point. But if, let's say, I have kind of nice pictures out there to kind of showcase what it can do, or even if you can put a video, it can kind of draw people into it. People tend to be visual learners or attracted to the visual things, and it goes a long way. And you want to design for a funnel. So let's look at an example here. Has anyone heard of Kiva.org? Kiva does microloans for people who, need money, like third world countries, and even within United States. It's you basically put money into the system, and you can loan money out to people. And these are people that need money to either build water irrigation systems, or if they need more education, or they're trying to stand up a medical service for their neighborhoods. But if you read how this goes, they're trying to tell a story. They say, make a loan, change your life. That pops out at you. And then there's more stories that they tell. It's like, these are different, causes, and they're trying to get you to lend. And then ultimately you go down here. It says it's not a loan. It's a loan, not a donation. Talks about how it works, gives you some metrics, and as you go down the webpage, it's supposed to draw you to eventually down here. And this is just one thing: make a loan today, get started. That's the funneling effect. Some websites you might not notice it; it's not as obvious, but in some, at the end of the webpage, it's going to ask you to do something. It's a call to action, and that's basically a funnel. Like if we use you guys been to this site, right? All of you have been to AI.camp.org, right? So you look at, okay, everyone can learn. AI, boom. And here, it already says, hey, if you just want to get here, apply. But then it talks about highlights. It tells you a story. Try something out. More information. More. And ultimately, boom, apply to AI Camp. Everyone. It's kind of a funnel effect. Are you guys able to follow? Like a lot of websites are trying to get you to eventually focus on one thing. And again, boom, another apply now, okay? So when you're building your own websites, it's kind of like that effect. I have a whole story. I might have some places where you can start if I already want to jump in. But ultimately, at the last very bit, pieces of the website. It's basically one thing they're asking you to do. And sometimes it's a call to action. Definitely, you want to use HTML to render your page, especially if, for example, our emotion detector at aicamp.com is used. The way it works is user clicks and uploads. Everyone's seen the demo, right? Someone clicks on the touch to see emotion, allows you to upload a picture. The picture is sent to the backend, and then there's something else that happens in the backend that calls it and evaluates it and does a prediction. It logs the interaction, and then basically it's going to have the browser redirect it to a prediction page, just like what we saw earlier, and then send the new information with the prediction. In your backend code that you're going to use today, you're going to see things like this, app route. So that's called a decorator. It's basically kind of a placeholder or adjective for a function that's being called. So in Flask, you'll see this, and you're going to use get and post methods, which is related to making a request and posting information back or posting it to the server. So the user inputs emotion.ai.camp.org. That's in a request. The request is going to do a get request, and your application is going to return the home function, which is this. The home function simply just returns your home page, which is here. I'm going to do this. It's going to load the picture. It's going to send it to the backend. It's waiting, and it returns. It says detected no emotion. All right, that was a bad picture. But the idea is that you start on one page and you get to a second page. And that's what that is. On the back end, when it pulls the image in, at the same time, it's going to pass your image through YOLO. YOLO, based on your weights, it's going to try to do some sort of detection. If your model is pretty decent, it'll return something with a picture with a box around it. So you're gonna have to kind of understand what are these things. There's something called YOLO_forward that forwards the picture through the network, and it's going to return the result a web page called results.html, and with some labels and old name and a fall name, and it actually generates a new picture with a box around it. And then when you're designing your front end, you're not going to be initially working with HTML, but once you design your front end, you're going to download the HTML. The HTML, you're going to have to kind of dissect it, because there's JavaScript. You're going to have it do like that button to upload. You're going to have to figure out, okay, how do I get the design HTML to work with the code that we have? We're probably not going to use this so much, but remember when I said, if you're coding JavaScript, you might have to do this in a pool or ocean. Again, there's a lot of things out there that may really simplify it, not just the JavaScript, but your HTML, which is frameworks. One particular framework that we use is Bootstrap. And in Bootstrap, in a framework, you can figure out how to use buttons, how to color the buttons, and if you want to drop down or something like that. Like when we do this prediction on motion.ai or the website you'll be building, how can you get the people that use your product to improve your algorithm? So remember about the first thing that we talked about at the beginning of the hour was you're building this AI thing, your AI model. What good is it if I can't have people using it or seeing it? And part of the key is getting feedback. So it's one thing to build and practice your codes. Another is if you really want this to take off, then one of the things that you need is feedback, whether it's feedback from your friends, whether it's feedback from your customers, whether it's feedback from your parents, whether it's feedback from people you don't like. How do you think you can use feedback to improve, whether it's even the website or the algorithm? Keep that in the back of your mind when you're designing your website this week. You're going to see things pop up. You're going to see things kind of cool. You're going to tell your story. Definitely have fun this week with what you're building, okay?